I'm now going to work out number 2. Find the area of the region in the first quadrant that's enclosed by y is equals to the square root of x, the x-axis, and the line y is equals to x minus 2. So we need to sketch this first. So first quadrant, let's start with y is equals to the square root of x, and then we have y is equals to x minus 2. Now, these two curves, x minus 2 cuts the x-axis at 2. Let me just, this is the x and that's the y-axis. So we know that this point here will be 2. Make it better. So we want to find the area enclosed by these two curves and the x-axis. So we want to find the area of this part here and this part here. We just want to find the area of the shaded part. But there's a reason why I'm dividing these two areas into 2. Well, because if you inspect, you can see that this area A is under, actually, let me use a black one. So A is under the graph y is equals to the square root of x, but the area B is between the two functions. Anyway, so we need to find the coordinate, not really the coordinate, the x value at this point here, where the two graphs intersect. So we say at the point of intersection, x minus 2 will be equal to the square root of x. So x minus 2 squared will be x, which means x squared minus 4x plus 4 will be equal to x. So x squared minus 5x plus 4 will be equal to 0. Factorize that, x minus 4, x minus 1. So x is equals to 4 and x is equals to 1. What this means is that this function y is equals to x minus 2 cuts the graph of y is equals to square root of x at 2 points. Now you have two solutions. Obviously we can see that it's cutting it at 1 point, but the reason why you have two solutions is, remember, this function here is an inverse of a quadratic function. So, but because you want a function, we just consider the first part of the function. The other part will be something like that. Okay, so this is the point where x is equals to 1. The one that you're seeing here, x is equals to 1. It's this part here. But we're not interested in that part. We're just interested with this part here. Okay, so this is where x is equals to 4, and this is what we can see there. So we have two solutions, but what you are going to do is we'll ignore one solution and just pick one that we are interested in. Just deleting this. So the only solution that's important to us here is this one. So x is equals to 4, or just 4. Okay, now that we have that, we can start finding the areas of A and B. So I'll just scroll down to create more space. So the area of A will be the integral from 2 to 0. This is 0. Square root of x, which will be x to power 3 over 2 over 3 over 2 to 0, should be 2 over 3 x to power 3 over 2, which will be 2 over 3 plug into 2 power 3 over 2, and that's it. Minus 0, of course, no need, right? 0. All right, area of B. Let me increase space. Will be, because B is between two curves, we'll have to integrate between two curves. So area of B will be integral 4 to, those are our limits, x to power a half minus x minus 2. Remember, the function above is the square root function, dx. So that will be 4 to x to power a half minus x plus 2 dx, which gives us x to power 3 over 2 over 3 over 2 minus x squared over 2 plus 2x for 2, which will be 2 over 3 x to power 3 over 2 minus x squared over 2 plus 2x for 2. Now, which means that our area will be, if we just increase more space here. So this means, I'll just come to the left so that I can be able to, 2 over 3, 4 to power 3 over 2 minus 4 squared over 2 plus 2 multiplied by 4 minus plug in 2 over 3 to power 3 over 2 minus 2 squared over 2 plus 2 multiplied by 2, which means I'll end up with 16 over 3 minus 8 plus 8 minus 2 over 3 to power 3 over 2 minus 2 plus 4, which is equals to 16 over 3 minus 2 over 3 to power 3 over 2 minus 2, which is basically 10 minus 2 over 3 to power 3 over 2. Okay, so that is the area of B. So total area will be the sum of both of this, 10 over 3 minus 2 over 3 to power 3 over 2 plus 2 over 3, which is the area of A, which gives us 10 over 3. That is our final answer. Okay. Number 3. In this graph, the regions bounded by the curve y is equals to x squared and the lines y is equals to 4 and y is equals to 1 is equal to the region bounded by the curve that. Okay, so we have two conditions here, and what basically they are saying here is the region bounded by the curve and the lines y is equals to 4 and y is equals to 1, which is that, is equal to the region bounded by the curve and the line y is equals to a. So this part. So those two are equal. Find the value of a. We may start by dividing these two. So I'll call this a, and this one I'll call it b. That way I can work out the area of a separately, the area of b separately, and then equate them. Okay, now first step here is we need to start by making x the subject of the formula. So y is equals to x squared. So x will be square root of y. Therefore, the area of A will be equal to 2 multiplied by, I'm multiplying by 2 because this and this are equal. So I'll start by finding that and just multiply it by 2. Okay, so 2 multiplied by the integral of 4a y to power a half dy, which will be equal to 2 in bracket y to power 3 over 2 over 3 over 2. This is 3. And the limits are 4a. Well, what will that give me is 2 in bracket 2 over 3 y to power 3 over 2 a to 4, which will be equal to 2 over 3 4 to power 3 over 2 minus 2 over 3 a to power 3 over 2. Let's scroll down, see what happens. Good. That will give us 32 over 3 minus 4 over 3 a to power 3 over 2. Okay, so this is the area of A. The next step is area of B. Now area of B, I'll do it the same way. Find that, multiply by 2, and I'll end up with the area of B. So area of B will be the integral, 2 multiplied by the integral, 2 multiplied by the integral from a to 0 of y to power a half dy, which will give me 2 into bracket 2 over 3 y to power 3 over 2 as 0. And if I plug in a, I'll just have 4 over 3 a to power 3 over 2. But we know that we are told in the question area of A is equal to the area of B. So what we are going to do is to equate these areas, find the value of A. So the area of A from our calculation is 32 over 3 minus 4 over 3 a to the power 3 over 2. Area of B is 4 over 3. So 32 over 3 minus 4 over 3 a to the power 3 over 2 is equal to 4 over 3 a to the power 3 over 2. Okay. This means that 32 over 3 will be equal to 8 over 3 a to the power 3 over 2, which means that a to the power 3 over 2 will be equal to 4. So a will be 4 to the power 2 over 3. And that will be our final answer.